In the first item, we are asked to find the resultant of two force vectors and expressed in the Cartesian coordinate system. Here are our two forces. There's our Cartesian coordinate system, x and y. We're going to need to know the net angle over to each. For that 210 pound load, that's going to be 25 plus 55, or 80 degrees. And for the 170, add up the 85 and 25, you'll end up with 110 degrees. So for the Rx component, all we have to do is sum up the x component of each force. So the 170 pounds, then multiplied by cosine of its angle, 110 degrees, plus the 210 pounds, then it's going to go with the cosine of its angle of 80 degrees. And note that when we reference the x-axis, use that cosine automatically, the plus and minus signs will inherently work themselves out as appropriate, and we'll get a minus 21.7 and change, rounded up to 0.7 pounds. And then likewise for Ry, we'll have 170 pounds, and now we'll use the sine of each of the angles, and that will be a net of 366.5 pounds and change, so that our answer here is that R as a vector equals minus 21.7 in the I direction plus 366 point in the J direction, and the whole units are pounds. A couple of things to note. One, we get this little odd thing here of this ad hoc approach of significant digits in statics. If it starts with anything other than a 1, we use 3 digits. And so we've done that in both cases. It does mean that these components look like they're not quite precise to the same level, and that seems a little odd. But that's just our straightforward approach in statics about how we round things. Also note that we don't write 366 without the period, because if we did that, it would look like it was exact to 366, and it's not. Note also 366.5, you might think you would round up to the higher one, but with the slight deviation back to our normal regular scientific digit or figure significant digit rules, then anything that's an even, we have a 5 sitting here. It doesn't matter what else is outside of the 5, but if it's a 5, we always go to the even number. Hence why you see it showing up like that. Now you might also have said, I don't really, or not comfortable with this whole cosine business, and you could have written this out as 170 times now cosine of 70 degrees, but now to get the direction right, you have to put the minus sign in there, plus the 210 pounds and cosine, again, of the 80 degrees. And of course, you'll get the same number of minus 21.7. So there is definitely more than one way to have gone about solving this.